Hello everyone, welcome again to my channel. Today we're looking at some mathematical questions. Um, Please, I want to just say if you find my videos very educating and interesting, please indicate by just clicking the like button and the subscription button so that you will not miss most of my videos. Okay, so let's look at this question. We want to show with complete induction that the summation of k all over k plus 1 factorial when k begins from 1 to n is equal to 1 minus 1 over n plus 1 bracket factorial for all n elements of a natural number. So solution. So we're asked to prove that this formula is true. Yeah, we begin with the base case. In base case, we set n to be equal to 1. So anywhere that we see n, we replace it by 1. So we go summation of k all over k plus 1, k plus 1 bracket factorial when k begins from 1 to 1 is equal to 1 minus 1 over. So we replace this n here with 1. We have 1 plus 1 factorial. Yeah. So summation of k over k plus 1 when k begins from 1 to 1, yeah, is going to give you 1. We are replacing k with 1 again because k is beginning from 1 to 1. We have 1 over 1 plus 1 bracket factorial equal to 1 minus 1 all over 1 plus 1 bracket factorial. Yeah, so we have 1 over 2, yeah, factorial equal to, yeah, we have 1 over 1 over 2 factorial. So this can be simplified to give you, we're simplifying this one further. Let's simplify this one further to give us 2 factorial over 1 over 2 factorial because we are taking the LCM of 2. So that this is going to give us 1 over 2 factorial is going to be, yeah, 2 factorial is 2 times 1, yeah, 2 times 1 minus 1 all over 2 factorial. Yeah, yeah, so you know that 2 factorial is equal to 2 times 1. All right, so that is how we got 2 factorial to be 2 times 1. So we have that 2 times 1 minus 1 is going to give us 1 over 2 factorial. So here now we're having from the left hand side we're having 2 factorial 1 over 2 factorial to be equal to 1 over 2 factorial. Which basically will give you 1 over 2 to be equal to 1 over 2. So the base case holds true. Yeah, so we project further to induction hypothesis. In induction hypothesis, we assume that the formula is true for n equal to m. For n equal to m. Okay, so that means we are now replacing n with m. So in this formula now, instead of n, we replace it with m. So we have summation of k all over k plus 1, yeah, factorial. K is equal to 1. Now instead of n, we replace it with m. K begins from 1 to m is equal to 1 minus 1 over m plus 1, yeah, factorial. So note that this can be rewritten to be, you can rewrite this to be equal to m plus 1 when we take the LCM of m plus 1 factorial. So we're having m plus 1 factorial minus 1 over m plus 1. So let's just leave it like this to enable us to compute or to simplify. Okay, all right. So in our induction step, yeah, we set m to be, which is now equal to m, we project it further to m plus 1, yeah. So we want to show that m, which is now equal to m, can be projected further to be m plus 1. Okay, yeah. So anywhere that we are seeing m now, we replace it with m plus 1. So we have still in this formula, we have k, summation of k all over k plus 1 bracket factorial. K begins from 1 to m, yeah, plus 1 to be equal to, let's make use of this formula now, this formula. So anywhere we are replacing everywhere we see m, we replace it with m plus 1 from here. So let's replace this m with m plus 1. So I have m plus 1, yeah, plus 1 bracket factorial minus 1 over m plus 1, yeah, plus another plus 1, yeah, m plus 1 bracket plus 1, yeah, factorial. So we have summation of k all over k plus 1 factorial when k begins from 1 to m plus 1 to be equal to, simplifying this further, this will cancel out so that you have m plus 1 over m plus 2 factorial. This is what is remaining. Now from the left hand side, that's here, we have this side is the left hand side, while here is the right hand side. Okay, so from the left hand side we have that summation of k all over k plus 1, yeah, factorial, k beginning from 1 to m plus 1 can be broken down, it can be disintegrated to summation of k over k plus 1, yeah, factorial, k beginning from 1, yeah, to m plus m plus 1, yeah, all over m plus 2 bracket factorial, yeah. This is the disintegration. Okay, yeah. Now what we have to do is to substitute the induction hypothesis, which is equal to, which is given as, remember the induction hypothesis, this one is equal to summation of k all over k plus 1, yeah, factorial, k beginning from 1 to m is equal to m plus 1, yeah, bracket factorial minus 1 all over m plus 1, m plus 1 what? Factorial. So we have to substitute this induction hypothesis into the equation. So what are we doing? We are replacing this. We're going to replace this with this. Okay, instead of this, we are replacing this with this. Okay, so that this is how it's going to look like. We have that summation of k all over k plus 1, yeah, factorial, when k begins from 1 to m plus 1 is, now let's replace this with this. So we have m plus 1, yeah, factorial minus 1 over m plus 1, yeah, factorial plus m plus 1, yeah, this one now comes, this one comes, this one comes. So you have m plus 1 over m plus 2, yeah, factorial. Yeah, but m plus 2 factorial can be rewritten. It can be broken down to m plus 2, m plus 1 factorial. Yeah, just like when you have 2 factorial, it is equal to 2 times what? 1. So it follows the same principles here. Okay. Okay, so you have summation of k all over k plus 1 factorial, k is beginning from 1 to m plus 1 is equal to yeah, this one is also equal to this 1 plus 1 minus 1 over m plus 1, yeah, factorial plus m plus 1 over, now replacing this m plus 2 factorial, replacing it with this one, replacing this one with this one, we have m plus 2, yeah, m plus 1 factorial. Okay, so it's now easier for us to take the LCM, of these ones, or the denominators. So let's replace this with s, because it's quite easier for us to write. So replace it with s. So taking the LCM of all the denominators here, we have m plus 2, m plus 1, yeah, factorial. Okay, so yeah, remember this is 1. So 1 into this, you're having what? M plus 2, yeah, m plus 1 factorial, yeah, minus m plus 1 factorial into m plus 2 into the denominator. You are left with m plus 2, yeah. Then this goes into this, you're left with what? 1 times m, which is what? Is giving us what? Plus m, yeah. And then we have 1 that is left. So that that s is equal to, remember we said that that m plus 2 m plus 1 factorial is the same thing as m plus 2 factorial. So we have to just carry this in mind, so that we're not substituting it into this equation. We're having m plus 2, yeah, m plus 1, yeah, factorial. Okay, sorry, let's replace this with this. So you're having m plus 2 factorial, yeah, minus m plus 2 plus 2, yeah, plus m plus 1 all over. Replace this again, have m plus 2 factorial. So that s is m plus 2 factorial minus multiplying through this, minus multiplying through this, you're having minus m minus 2, yeah, we have plus m now, plus 1, okay, you have m plus 2, yeah, factorial. So that s, yeah, let's cancel out. Let's look at what will be cancelled out. Yeah, minus m can cancel plus m, yeah, so that we now have m plus 2 factorial. So minus 2 plus 1 is going to give us minus 1 all over m plus 2, yeah, factorial. And this can also be written as 1 minus 1 over m plus 2 factorial. Yes, we have proven that s, you know that s, we wrote s is summation of k over k plus 1 factorial, k beginning from 1. That's the meaning of s. We have proven that it is equal to 1 minus 1 over m plus what? 2. M plus 2 factorial. So it's well proven. Okay, so that's the end of this work. Feel free to drop your likes and your comments. Yeah, and don't forget to subscribe for more of my videos. Thank you. Goodbye.